Welcome viewers, it's me Zafar. Hope you're fine. Thank you for joining Chemscope. As we have been discussing the periodicity of properties or periodic table, and now we are going to discuss electron affinity, that is the part of periodicity of properties. What is electron affinity? Affin you mean love, likeness. Affin you mean likeness or tendency. Electron affinity technically means the amount of energy released when an electron adds up in valence shell of an isolated atom to form a uninegative ion. This is called electron affinity. When amount of energy released when an electron is added to a gaseous atom to make a uninegative ion. Here we have an element and add one electron to it. It makes uninegative ion and energy is being released. Here is an actual example when we add an electron to chlorine and energy is released, that is 349 kilojoule per mole. Why energy is released? In fact, when electron is away from the influence of the atom, it's at infinity, and we know in upper shells are away from nucleus energy, electrons have more energy. In fact, we move this electron to a shell, as a result it loses energy. That is called electron affinity. We add an electron to a gaseous atom and energy is being released. What are the trends? In a period from left to right, electron affinity increases. Why it's so? Because the size of the atom decreases and nuclear charge increases. That binds the extra added electron more tightly. That is why more energy is released. While in a group from top to bottom, electron affinity decreases. Why it decreases? From top to bottom in a group, there is increase in shielding effect. As a result, extra bonded electron is not bounded as much tightly as in case of period. In a group from top to bottom, electron affinity decreases due to increase in shielding effect. As a result, extra electron is not bounded much more tightly, rather it is bound less tightly. We will see some trends in first group. We will see here is lithium, sodium, potassium, rubidium, cesium. From top to bottom, electron affinity is being decreased. Why it is being decreased? Shielding effect increases. As a result, extra added electron is not bound so tightly. So electron affinity decreases in case of first A group. In case of halogen, that is at the right corner of the periodic table, halogens, fluorine, chlorine, bromine and iodine, from top to bottom atomic size increases. As a result, electron affinity decreases from top to bottom. There is a shielding effect is also increasing from top to bottom. As a result, electron affinity decreases. So we conclude, in a period from left to right, ionization energy increases, but in a group from top to bottom, electron affinity decreases. In a group from top to bottom, electron affinity decreases. We'll see second A group, which include beryllium, magnesium and calcium, strontium, barium. They have complete s orbital, so their electron affinity is considered to be 0. Likewise, 0 group elements, that are helium, argon, krypton, xenon, they also have electron affinity value 0 because they have completely filled valence shells. So no electron is added, they have no capacity, they have no vacancy, they have no partially filled or empty orbitals in their valence shell. So we generally consider their electron affinities as 0. So we conclude that electron affinity is the amount of energy released when an electron is added to an isolated gaseous atom. It increases in a period from left to right and decreases in a group from top to bottom. Hope so you must have liked this video. Thank you for watching. Bye.